Okay, so let's try some examples. So the first one, we're taking the derivative, dy dx. We have an outer and an inner function. So the inner function here is in here, and the outer function is the power. So I need to, so we have, let's see here. We have to take the derivative of the outer first, and then multiply by the derivative of the inner, like that. So the outer function is the power rule. So it's going to be 3 times x squared plus 4, and then subtract 1, so to the second power. That's just the outer, and all I'm doing is the outer part. I'm not touching anything on the inside. And then we're taking the derivative of the inner, which is 2x. I can simplify that a bit, which is going to be 6x x squared plus 4. And the preferred form is actually in factored form. So I don't want you to expand this out and distribute the 6x. That would be a complete waste of time because it's much better to have it in factored form. It lets us find where the derivatives are 0 or undefined much easier. Pause the video and try part B. So just to highlight, I forgot to do it on the first example, but these are the parts that correspond. The same in here, the inner function was 2x cubed. The outer function was the square, the square there, like that. The general form, when you have anything raised to a power, it happens so often that they created a general form for the power rule. That means that essentially you do the power rule times the derivative of the interior. There's lots of different ways of writing that. Essentially, the way to prove it is to use the chain rule. So it's saying what we just did before. Since u is equal to u of x to the n power, I can rewrite that as just u to the n. We can apply the chain rule. So that's where we're going to start. I'm going to use the chain rule, dy dx is equal to, in yellow, it's going to be dy du, which is the outer function. So in all of our stuff, the outer function is going to give me the derivative of the outer function. That's that part there, the derivative of the outer function. The outer function is right there. It's just the n. And then I'm going to multiply that by the inner function, which is u of x. So du dx, the derivative of the inner function, du dx, the inner function there. So that's using the chain rule. Now, I'm just going to substitute in then the pieces that I know. I'm going to take the derivative of u to the n with respect to u, that's the outer function, and the derivative of du dx is that's u prime, that's the inner function, that's the piece we already need, so that part is fine. And then I'm just going to use the power rule to get n times u to the n minus 1. And essentially, we have what we needed to prove. I can use a bit of substitution to get the other forms, but the power rule, the general power rule just means take the do the power rule for the outer function and then multiply by the inner function, the derivative of the inner function. So let's try that for this one here. We have y prime is equal to, used power, which is 4, and then 4x minus 3x squared to the third. That's the power rule. So that is in yellow here, that part there. That's the outer function. And then the inner function will be this part here. That's going to come next here. I might as well just highlight it. So that is going to be, it's going to be 4 minus 6x, like that. Now, technically, right now, you're done. But the preferred form is factored. So this one can factor a little bit further. So in this case, I get y prime is equal to, now, if it was free response, it just asked for the derivative, you'd be done. Most likely, you'd be asking the multiple choice portion of it, and they will have it in factored form most of the time. So if I look at the inner function, I can factor out a 2, and that's going to give me, I'm going to leave a little bit of space because I can also factor something out from the other one. So here, I can factor out a 2, and then I'm left with 2 minus 3x. And then the outer function has the 4, but I can factor out an x from in here. I'm just going to squiggle under here from just the inner part of that. And when I factor out an x from that, I'm technically factoring out an x cubed because there's 3 of them. So there's 3 4x minus 3x squares. I can factor out an x from each one of them. So that's going to produce an x cubed there. And that's going to give me a 4 minus 3x to the third power. And that's just to polish it off a little bit, x cubed. Now, why is this beneficial like that? Ooh, that's a 3. Well, it's because later on we're going to be, one of the important things with derivatives is to figure out where the derivative is equal to 0. Well, when it's in factor form, it's much easier to find that. Each of these factors will then be set equal to 0, and I know that this derivative would have to be 0 when x is equal to 0, that's from the first factor. When x is equal to 2/3 is from the second factor. And from the last factor, when x is equal to 4/3. So there's 3 places I know that the derivative would be equal to 0. All right, pause the video and try B on your own. Try and see to get it in factor form if you can, to polish it off a little bit. Like I said, the directions don't say that, but it's good to practice. So I have the 2 pieces highlighted. One is not in factored form, and the second one is I polished it off and factored it a little bit. And to just color code it, inner function, this is the derivative of the inner function. Outer function, that's the cube. Here's the derivative in yellow of the outer function.